This Navy diver wears a standard deep-sea diving outfit, a protection against the water in which he works, and a container for the life-supporting supply of air which he receives from the surface. Safety and efficiency require that the diver be thoroughly familiar with the construction, assembly, and use of his diving equipment. This film will show how the many parts of the standard deep-sea diving outfit are assembled, a process called dressing the diver. The standard deep-sea diving outfit is composed of the dress, helmet, and the breastplate, which together form a watertight enclosure surrounding the diver. The weighted belt and shoes used for overcoming the positive buoyance of the inflated dress, and the system of valves by which the diver regulates his air supply. Assembling these parts correctly is vital to the diver's safety, and thus, prior to dressing the diver, each must be inspected and tested. First, visually inspect the diving dress. Examine the fabric for tears, worn spots, or loose patches. Check the rubber collar for torn spots or excessive wear, especially at the stud bolt holes. Make sure that the leg flap lacings are in good condition and not worn to the breaking point. If any defects are found, place the dress aside for repair and select another dress of satisfactory condition. In examining the breastplate and helmet, first check the number stamped on each item, including the breastplate straps. The number must be the same. These parts are not interchangeable with like parts of another outfit. The number identifies the parts that go together to form a tailor-made unit of matching parts. With your fingers, check the 12 studs on the breastplate, making sure that none of them has become loose. Try the fit of the breastplate straps on the breastplates. They should go into place easily and conform to the curvature of the breastplate. Notice that to avoid mix-ups, the front straps are clearly labeled. Turn the wing nuts down on the studs to make sure that no threads have been damaged since the last dive. The copper and brass of which the outfit is made are relatively soft metals. Being soft, the threads are susceptible to damage from careless handling. Notice that 4 of the wing nuts have heavy flanges. These go on the studs where the ends of the breastplate straps join each other. Look for worn areas in the breastplate lanyards. If there's any doubt, replace them. Remember, these lanyards secure the all-important air hose and lifeline. The leather gasket recessed into the top of the breastplate makes a seal between breastplate and helmet. Make a visual inspection for tears in the leather and for cleanliness. Dirt or debris could prevent proper seating of the helmet, thus causing leakage. Apply a light coating of neat's foot oil to the gasket. This will keep the leather soft and pliable so that it makes a good seal. Now, double-check the helmet gasket by fitting the helmet to the breastplate. It should turn into place easily, but with some resistance. The helmet faceplate should face directly forward. And the safety latch on the breastplate should line up properly with the dumbbell on the helmet. Check these for security and proper operation. Take a close look at the helmet ports, especially for cracks or dirt. Clean them if necessary. Underwater visibility is seldom good, and dirty ports would further reduce the diver's vision. The faceplate is the only viewing port that opens. Check the condition of the rubber gasket and the operation of the hinge and swiveled wing nut which clamps the faceplate against the gasket. Make sure the cotter pin is in the hinge pin and secure. The two goosenecks at the back of the helmet are extremely important. This one admits the diver's air supply, and this one secures his combination lifeline and communications cable. Be sure they have not been knocked loose and that the threads are clean and undamaged. No part of the testing and inspection operation is more important than the attention given to the diver's air valves. Let's begin with the two valves built into the helmet. First, the exhaust valve. Check the operation of the hand wheel. It should turn freely. Operate the exhaust valve chin button. It should depress easily and return immediately when released. Pull the chin button upward, as the diver occasionally does with his lips, to make a temporary adjustment in his buoyancy. Again, it should work easily and return when released. Operate the chin button in this manner several times. Remember, the correct operation of his exhaust valve is important not only to the diver's efficiency, but also to his safety. Next, the spitcock at the left side of the helmet. This is a secondary exhaust valve and is used to make minor adjustments in the diver's buoyancy. It's a simple sleeve valve. The only test necessary here is to operate the lever, making sure that it has enough turning resistance to remain fixed at any setting. Now, let's look at the remaining two valves, each concerned with air supply. The air control valve regulates the amount of air admitted to the diving dress. Again, the regulating hand wheel should turn freely so that the diver has no difficulty in making adjustments in his air supply. However, it must not be loose. Enough resistance must be felt to prevent an accidental bump or blow from turning the hand wheel and thus altering the diver's buoyancy. Make sure the cotter pin is in place to prevent the hand wheel lock nut from backing off. Each of the male threads machined into the body of the air control valve must be clean and free of distortion. Check the link and eye pad used to secure the valve to the breastplate. Excessive wear or damage is seldom found, but be sure. The last of the valves is the safety air non-return valve, usually referred to as the non-return valve. Remove it from the gooseneck at the rear of the helmet and check the condition of the threads. You'll remember that the non-return valve is a spring-loaded one-way valve. Air can pass through it into the helmet, but it cannot travel in the opposite direction from the helmet back into the air hose. Check this by blowing a mouthful of cigarette smoke into the end of the valve that has the female thread. No air or smoke should pass through the valve. If it does, discard the valve and use another. There are two types of non-return valves in use. This newer type has a heavier spring inside, and the valve body is made in two pieces rather than one. The test is the same. Smoke blown into the end of the valve having the female threads should not pass through. Remember, this is one of the diver's most important safety devices. Never omit this test. Be positively sure the non-return valve is in perfect working order. Now reinstall the non-return valve on the helmet gooseneck. Next, carefully examine the belt, shoulder straps, and jock strap. Look for tears, nicks, worn areas, or elongated buckle holes. Treat these items occasionally with a coating of neat's foot oil, well rubbed in. In addition, the tensile strength of these leather items should be periodically checked in this manner. A buckle is secured to the overhead, and the item to be tested run through the buckle. If the belt, shoulder straps, or jock strap can support the weight of a man weighing 160 pounds, its condition is satisfactory. To complete the testing and inspection process, check the diver's wrist straps and shoes for excessive wear and tear. Apply neat's foot oil if necessary. Be sure the shoe lacings are not frayed where they pass through the eyelets. If there's any doubt in your mind about the condition of any item of the diver's equipment, check it out with the diving officer or diver in charge. It's better to ask a question than to take a chance on the safety of a human being. Before dressing the diver, connect the air hose and the lifeline to the helmet goosenecks. Do not, repeat, do not oil the leather gasket inside the lifeline gooseneck. Remember, the lifeline carries the communications cable. Oil on the contact points of the cable would interfere with the operation of the intercom system. Tighten the connections hand tight, then finish with a wrench. Be firm in tightening these connections, but don't use too much muscle. Stripped threads might get the diver into serious trouble. Check the air supply by opening the air control valve. You'll be able to hear the air rushing into the helmet. Dressing the diver is mainly the work of two men, the diving tenders. They are supervised by the diving officer or the diver in charge and assisted, where possible, by the diver himself. The diver is prepared for diving by donning one or two sets of diver's underwear, his choice determined by the temperature of the water and the amount of physical activity required by the job. To begin the dressing process, the diver slides feet first into the diving dress, the tenders assisting in drawing it up. The diver helps by worming his arms into the sleeves as the tenders work the dress over his shoulders. The diver assumes this bent-over position so that the tenders can conveniently lace up his leg flaps. These are drawn up snugly, but not so tightly as to restrict circulation. Tenders work as swiftly as they can, consistent with safety, out of regard for the diver's comfort. On the surface, the diving outfit is not a very comfortable one. Note how the ends of the lacings are tucked in under the leg flaps. This, of course, is to keep them from fouling. Tenders steady the diver as he steps into his shoes. They draw the lacings up firmly and tie them off with a square knot. Straps go over the ends of the lacing, again to avoid fouling. Buckles must be outboard. If they were inboard, they might snag on each other and trip the diver. Next, the helmet cushion, the horse collar as divers call it. This is an optional item. Some divers use it, some don't. All divers, however, should learn its use. It's a pad to protect the diver's shoulders and simply slips over his head. One tender works the horse collar under the bib of the dress, while the second tender gets the breastplate. Now, the breastplate goes over the diver's head, carefully. There's not too much clearance. Eyelets and halyards, of course, are at the front. A tender tucks the halyard ends up inside the breastplate to get them out of the way. The next step is the all-important watertight seal between the dress and the breastplate. Working one on each side of the diver, the tenders maneuver the rubber collar over the breastplate studs, starting at the back and working toward the front. Alternating from side to side, they manipulate the stiff collar by pulling on the bib. The fit of the collar to the breastplate must be smooth, without bulges or wrinkles. A copper washer goes over the bottom front and bottom rear studs and over the top right and top left studs. These distribute the pressure under the joints between the breastplate straps to prevent gouging and chafing of the rubber collar. Next, the breastplate straps. These are custom fitted in the manufacturing process. Each of the 4 straps must be placed in its own particular position. Getting them in the right place is easy. The front straps are clearly marked. The tenders now install the 12 wing nuts on the breastplate studs, being sure the flanged wing nuts are over the strap joints, and hand tighten each one. The tenders, one working at the back and one at the front, use the wing nut wrench for the final tightening. Notice the grasp the front tender has on the top opening of the breastplate. This is to protect the diver's chin, as the torque of tightening the wing nuts causes the breastplate to tilt and twist. To equalize pressure, each tender tightens from bottom to top, omitting the wing nuts over the strap joints. These 4 wing nuts are tightened in this order: bottom front, bottom rear, and the 2 top ones at the same time. As a double check, in the interest of safety, one tender now tries each of the 12 wing nuts with his wrench to be sure that none has been skipped. Now he removes the wing nut on the longer stud at the left front of the breastplate, where the eye pad of the air control valve will be secured. The installation and tightening of this wing nut cannot be omitted. Repeat, cannot be omitted. It must be installed and tightened in the proper sequence in order to make a tight waterproof seal between the dress and the breastplate. To protect this exposed stud, the diver covers it with his left hand. It takes both tenders to carry the 84-pound belt. Each holds an end and a shoulder strap, being careful to grasp the strap close to the belt. If they were to take a higher grasp on the shoulder strap, the heavy belt would tend to swing like a pendulum and might knock the wind out of the diver. The tenders place the belt around the diver's waist with the buckles at the rear. They lead the shoulder straps so that they cross at the bottom of the front lower stud, pass outside the top stud at each side, and cross again at the bottom of the rear lower stud. This keeps the belt from shifting while the diver works. Each tender now secures one of the shoulder straps, passing it through the appropriate buckle attached to the belt weights in the rear. One tender fastens both the belt buckles. The diver stands, and the other tender passes the jock strap between his legs. Pulls it comfortably tight as the diver bends and straightens to check the fit. Fastens the buckle and tucks the loose end of the tongue out of the way. Each tender buckles on one of the wrist straps firmly, but not so tight as to restrict circulation. The inflated suit tends to elongate. The wrist straps keep the diver's hand seated in the gloves. The helmet is the final item to be fitted in dressing the diver. The air hose and lifeline are already attached. To keep these out of the way, the tender leads the air hose over the top of the left port and the lifeline over the right. He lifts the helmet by grasping the side ports. The helmet is hard and heavy, so the tender places it over the diver's head gently. He positions it so that the faceplate faces a little to the diver's left. When turned into place, the faceplate of the helmet should face directly forward, and the marks scribed on the helmet and the breastplate should be aligned, or nearly so. The faceplate is open now, so the diver can breathe and talk until he is ready to go over the side. The dumbbell is dropped into place, the safety latch closed and secured with a cotter pin. The air hose is passed under the diver's left arm, and a tender slips the iPad of the air control valve over the long stud of the breastplate. He reinstalls the wing nut now, using the wrench to tighten it firmly. Now the tender lashes down the air hose, taking 2 round turns with the halyard and tying off the ends with a square knot. In doing this, the tender takes care to ensure that the air control valve hangs conveniently to the diver's left hand for easy adjustment. The diver's lifeline, which also carries his communication cable, is passed under his right arm, and a tender lashes it tightly with a halyard on that side. He again takes 2 round turns with a halyard and ties it off with a square knot. And now, a last-minute check on the diver's intercom.
Topside, Red Diver. How do you hear me?
Red Diver, topside. Hear you loud and clear. How me?
I hear you the same.
The diver closes his exhaust valve all the way, then opens it by giving the hand wheel 2 1/2 turns. He'll adjust the air control valve as soon as he's submerged on the diving ladder. The final step in dressing the diver comes when the diver feels that all is ready and gives this signal.
Button her up.
The tender closes the faceplate, winds the wing nut down finger tight, and uses the wing nut wrench to secure it tightly. The dressing of the diver is complete, and the diver is ready to go to work. 2 men tend the air hose and lifeline immediately in front of the diver to steady and support him as he moves cumbersomely in the heavy working uniform of the deep-sea diver. In his working environment under the sea, the diver is always conscious of the importance of his equipment. His gear is well designed and well made. The assembly of the gear around the man, or dressing the diver, is equally important to the diver's efficiency, to the accomplishment of the Navy's business, and to the safety and welfare of the man who wears the gear.